Hello friends, today we are going to see the IEEE 3-bus system for load flow analysis or power flow studies of the 3-bus system. In this case, we'll have the bus, the generator and the load when we can solve it by using GS or NR method using the power load simulator software. So we can calculate the total megawatt losses and the total MVAR losses. And according to the transmission line losses and also the transmission line megawatt and megavar output. So we can click it in the new case, so another it's opened, so we can draw by clicking network, then just click bus and we can click it the bus here. So from the bus we can write the bus name just like bus 1, and we can arrange the orientation by clicking right, up, left, down. It must be up. In the bus information, when it is a slack bus, it must be 1.05 bus voltage in per unit, but the angle is 0. And you can click the system slack bus dialog box here, right, then click it, okay. Then the bus 1 is created here. Another bus must be created because it's a 3-bus system, so you can draw another bus here by name it bus 2 for the bus name. It's also up, the bus information, it's 1, 0, and click it, okay. Click it, okay, and here is the bus 2. Another bus must be connected here. It's a bus 3, so it must be renamed as bus 3, and it must be right or left, and click it, okay. Click it, okay. Then we are going to pick the bus field. The bus field for the bus 1 must be the field value, it must be 1.05, the bus voltage, and the digit to write to decimal, it will be 4 or 5 for your convenience. So 1.05 per unit is picked up. And another field, the bus field is picked, and we can click it on bus 2, and it must be, here it is 1, and it's 4, just click it, okay. For the bus 2, we can click the bus field here, and we can click for the field value 1 and click OK. In this case, we have already built the 3-bus configuration, and we can add the network, the generator, the load, or the transmission line one by one. Just click the generator here, and the generator, it is installed on the slack bus 1. So we must arrange the bus, the one generator, the megawatt output. We don't know the value of the megawatt output for the power controlling mechanism of the generator, so we must set just 1000 value for the megawatt, and the set point voltage will be 1.05. The display information, we can arrange by clicking layout, the orientation, right, up, left, down. It must be on the left side. And the rotor shape, it must be the dog bone for convenience. So click it. Okay. Then the generator is connected to the bus 1. You can drag here the bus 1. Bus 1. You can drag it. And you can simply arrange the generator here. So this is the bus 1 generator output, the generator value, and we must connect the transmission line so far. So transmission line is built from bus 1 to bus 2. Then click it. Okay. The transmission line will have the series resistance value, the per unit impedance parameters. So the series resistance in our case is 0.05. In our example, the series reactance is 0.08. In the display mode, the pixel thickness must be 2 for convenience, and other one will be fulfilled. Just click it. Okay. Then this is the bus 1 to bus 2 transmission line. We can draw the transmission line again here by click it. Bus 1 2, bus 1 2, bus 3. Then we can fulfill the requirements for the bus 1 and the bus 2. In this case, in our case, 0.03 is the series resistance value, 0.03, and for the series reactance value, it will be the 0.06. And in the display section, we can pixel thickness, it must be 2, and we can we'll have the here, and we must draw the transmission line for the bus 2 and bus 3. So click it here, just wait your point, click, then again click, then this is the transmission line bus 2 up to 3. It is 0.034 and 0.047. In the display section, the pixel parameter is must be 2, and we can select OK. Here it is, all about the transmission line, and also we must draw the load for the bus 2 and for bus 3. And for the bus 2, we will have 247.7 megawatt value, 247.7 megawatt value, and the MVAR is 150. It must be on the right side, so click OK. Here is the load value, and also we will have the load value for the bus 3 um, that is 146.5, 146.5 for the mwatt value, and 48.9 for the mvar value, and it must be down. The orientation must be down, and we can click OK. Here is the mvar and megawatt value for the load on the bus 3. So friends, here it must be in 2 digits, because the field value is 2.248. It's not okay, the digital to write the decimal. 247.7, it must be digit 2, and again 147 megawatts. It's not the value for the load, it must be to 146.5, and the digit of the right decimal must be 2 here, and click it. And also the 49, it's not 49, it's 48.9 megavar for example. So we must put 2, and it must be directly converted. And the transmission line, it must be click it by the it must be always show value in percent, yes, and we must display the view pie chart display options. We can click it here. We can click it here. So here we must click the total power MVA, the display gauge values in percent, and always use in limiting flow, and the nominal color. It's all about your convenience. I would like to take the green color, then click it OK. Then the MVA value, it must be 1000, because we don't know about the value. Then the other one, it must be 1000, and always show value in percent, and the view pie chart display option is the same for all. If you did it for one bus, from one bus to another bus, then it will be the same for the others. It will be the same for the others. So as you can see here, display always total, and click it, just simply click it OK. And for this one, you can make the mvar value 1000, and click it OK. Friends, it's all about the you have end the all about the process, but now in this case we must run our simulation. So in our simulation, if you run it, you can click it on the tools and just solve by using these methods. For our case, Gauss-Seidel method will be chosen. And here is the power flow. It is all about the power flow. It is all about the power flow in this case. So for your conveniency, we must know the bus systems on this bus system. You can change all of the values here by using polar NR, the DC power flow, the single solution, the fast decouple, the decouple solution, by just clicking log, and we must clear this window. Then we must stop here and we must clear on the log section the clear window, and we just run on the other side. It is all about the flow for the power condition. So friends, we must draw the or we must put the m watt and m var value for each of these components, each of the transmission line, and the m var and m megawatt losses for the transmission line losses. So we must uh, uh, draw here by clicking draw, edit mode, click it draw, then just click it field, and here is the transmission line field. Just click it here, and the megawatt value, the field value, it must be 2 or less, it must be 2 or more, but the megawatt value, it must just click it. Okay, then this is the megawatt value for the transmission line, and we must click again for the transmission line field for the mvar losses, mvar output, pass 1. No, click transmission line field and click here. Then after click it mvar flow, the mvar flow is here. Here is the mvar flow, and also we can click it transmission line field for the losses here. Put the losses here, megawatt losses. Here is the loss, 36.36 megawatt is the loss. Again, transmission line field. We must put the mvar loss, mvar losses. Click it OK. Then this is the mvar loss. Here is the mvar loss. We must delete transmission line field for the pass 2 section. What flow 183 megawatt is here, and also field transmission line field. The mvar losses. No, it's not the mvar loss. I mean the field, transmission line field. It is the mvar flow. It's mvar flow. Here is the minus sign in the connection of the buses. It indicates the connection of the buses. So in the field again, we must put transmission line field for the m watt flow for the bus 1 and bus 3. In the field section, we must put the transmission line field. So we can click it here, and we must know the mvar flow. The mvar flow is here, and also the losses. Loss. the MVAR loss. Also, we must click transmission line field here, the MWatt flow. And also we must click the transmission line field for the megavar loss, megavar flow or MVAR flow. For the MVAR flow, and also we can click it the transmission line field, and we can click the MWatt flow here. Transmission line field, the MVAR flow. Here is the MVAR flow, and we must here is the loss, megawatt losses. Transmission line field, the MVAR losses, 6 MVAR, and also we must know the transmission line field for the megawatt power flow. For the bus 3, it is 68 megawatt, and for the MVAR is 71 megawatt. This is all about the power flow analysis, the Gauss-Seidel, the Gauss-Seidel, the Gauss-Seidel. Solve the again the Gauss-Seidel. So run. It's all about the power flow. It goes from here. The generator, it will have 457 megawatt in 298 megavar. You'll have the transmission line losses here, 36 megawatt, and also you'll have 48 megavar. This is the total. It's not a total power loss in megawatt and in megavar, but it is all about each pass from one to another. It indicates that, but we must put the total megawatt losses and megavar losses. So in this case, we must know the area field mechanism. The area field mechanism. Here you can just click it field, area field, then the area field, the megawatt load, the megawatt losses. This is all about the megawatt losses, and also you can know about the megavar losses of the three-pass IEEE three-pass system. It's all about the load flow analysis. So the megavar losses for the whole three-pass system is 98.897 megavar. So can text here in the background. I think this is a total power losses in this is megawatts. This is total losses, and also the just put total power losses in megawatt is 62.6246 megawatt, and the total power losses for the megavar is power losses of the megavar is 98.897 megavar. It's all about, my friends. This is all about the three bus system mechanism, and if you have any question about it, you can comment in the video. So it's all about for the three bus system IEEE load flow analysis. In the next lesson, we are going to see uh, the Newton-Raphson method, and also we can test this software by Dix Island Power Factory or by using ETAP, and we can compare and contrast the values by each simulation software. So friends, for the time being, I would like to say thank you, and try to subscribe to my channel, like, comment, and share. Thank you, my friends. Goodbye.